Hello, my name is Yafalong. Common metric is 11 TKA 19F1001. Today I want to do the experiment is about the determination of the biological oxygen demand. Objective to find the biological oxygen demand extracted by the given sample of wastewater. Apparatus use BOT bottle, pipes, conical flask, validated beaker, Doppler BOD incubator, and ECT. Solution use manganese sulfur solution, alkali iodide azide solution, corn sulfuric acid, sodium trisulfate solution, starch indicator. Description: biological oxygen demand, or BOD, is amount of oxygen consumed by the organism in breaking down the waste. Step 1. Take 200 ml of the sample in 2 BOD bottles and dilute it with distilled water by filling the water up to the bottle neck. Put the test sample at 200 ml. Fill out the bottleneck. Fill out the water to the bottleneck. Label the sample as sample A and sample B. While sample bottles are completed, fill up to the neck to avoid mixing of air bubble with the sample. Step 2. Add 1 ml of magnesium sulfuric MnSO4 solution to bottle name sample A. Care should be taken to avoid the bubble. And then step 3. Add 1 ml of alkali iodide azide solution to sample A bottle. Care should be taken to avoid the bubble in the BOD bottle. Step 4. Mix the solution by inverting BOD bottle upside down for 25 to 30 times and allow the precipitate to settle down at the bottom. Allow the precipitate to settle down for a few minutes. Step 5. Add 1 to 2 ml of concentrated H2SO4 carefully without forming air bubble. Squeeze the paper bulb and dip paper into the H2SO4 solution. Press up the arrow on the bulb to take the liquid up into the paper. Press the down arrow on the bulb to release the liquid into the BOD bottle. Step 6. Mix the solution by inverting the BOD bottle till all the precipitate dissolve. Shake it to 25 times. Step 7. Take 200 ml of sample in a conical flask using paper. Step 8. Take 0.025 Newton sodium thiosulfate and A2S202O2 solution in the barreted. Step 9. Treat the solution agency and A2S2O3. Edit starts when the color of the solution changes to paler yellow, then continue the duration till blue color becomes colorless. Initial battered reading 0 ml. Open the knob to start the liquid running into the conical flask. Cross when the color was changed, and then add 1 ml starch into conical flask. Cross the knob when the color was changed. What is the normality of sodium thiosulfate solution taken? 0.025 N. The final barreted reading is 6.5 ml. Observation: the volume of the sample milliliter is 200. Barreted reading millimeter. Initial is 0. Final is 6.5 ml. Volume of Na2S203. Final value time by initial value milliliter is 0.05 ml. Which of the following indicator is used during the duration? Touch. Step 11. Keep the sample B in the BOD incubator for 5 days at 20 Celsius. Set the temperature to 20 Celsius and wait the 5 days. After 5 days, take out the sample B. While sample B is kept in BOD incubator to prevent the DO pollution via photosynthesis. Step 12. Add 1 ml of MnSO4 solution to BOD bottle named as sample B. Sample B is kept in incubator at 20 Celsius temperature. Step 13. Add 1 ml of alkali hydroxide solution to sample B. Care should be taken to avoid the bubble in the BOD bottle. Step 14. Mix the solution by inverting BOD bottle upside down for 25 to 30 times, then allow the precipitate to settle down at the bottom. Allow the precipitate to settle down for a few minutes. Step 15. Add 1 to 2 ml of concentrate H2SO4 carefully without forming a bubble. Squeeze the paper pulp and dip the paper into the H2SO4 solution. Press out the air. Allow the bulb to take the liquid out into the paper. Put the H2SO2 carefully in the sample B. Press the down button arrow on the bulb to release the liquid into the BOD bottle. Step 16. Mix the solution by inverting till all the precipitate dissolve. Step 17. Take 200 ml of sample in the condenser flask using paper. Step 18. Take sodium thiosulfate Na2H2O3 solution in the barrette. Step 19. Titrate the solution agency 0.025 N Na2S2O3. At this touch, when the color of the solution changes to pale yellow, then continue the titration till blue color become colorless. Open the knob to start the liquid running into the conical flux. Initial barometer reading at 0 milliliter. Close the knob when the color solution condensation flux and change to yellow. Edit 1 milliliter touch into condensation flux. Open again. Do it. Close the knob when the color solution changes to colorless. After that, the final barometer reading is 2.7 milliliter. Final observation of sample A. Volume of the sample milliliter is 200. Sample B is 200. Barometer reading milliliter. Inertia 0 at A, 0 at B. Final is 6.5 at A, 2.7 at B. Volume of Na2S2O3 is final value. Divide the inertial value milliliter is 6.5 at A, 2.7 at B. Inertial DO formula is inertial dissolved oxygen level Na2S2O3 multiplied by VNA2S2O3 multiplied by 8000 divided by volume of the sample A. Normal of the Na at A2S2O3 is 0.025 N. VNaS2O3 is volume of Na2S2O3. So we get the answer is 6.5. The final DO, final dissolved oxygen level, is also Na2S2O3 multiplied by VNA2S2O3 multiplied by 18,000 divided by volume of the sample B. The normal of Na2S2O3 is same 0.025 N, and the volume also same is the Na2S2O3. The BOD given sample is 1900. 190 is because the formula BOD is DO divided by DS multiplied by D, or DO minus by DS divided by F, where the DO is inertial DO of direct sample, DS is DO of sample after incubation, F is dilution factor 1 divided by D times by is the 0.02. D is dilution 50. So the exact answer is correct. That's it. Is my experiment. Thank you.